Okay, so welcome members. In today's lesson, today we are going to see how do we get an argument of a complex number. Now, argument of a complex number today will be based on the real part and then the imaginary part. Now, if we are given a complex number z equaling to x plus iy, the argument of that complex number is given by an inverse of y over x. Now, to get a complex number, to get argument of the complex number, we always base on the quadrant in which it is located. So we have, you know that we have four quadrants. We have this, we have this, we have this, we have this. Now, if it's this one means that it's positive real, positive imaginary. This one means that this one says that it's always the real, this is always the imaginary. So it's that this one is negative, positive here, negative, negative here, positive, negative. So that's how we bring the angles in those quadrants. Now we are going to see that if we have z equal to x plus iy, then its argument is tan inverse the real part, the imaginary part over the real part. Then properties of argument, so that argument is they are behaving as logarithms. So if we have argument of z1, z2 is the same as argument z1 plus arg of z2. We can note it by just writing the word arg. If you have in arg z1 divided by z2, it's the same as subtracting. And if you have z arg, z power n, it's the same as this power coming here and multiply there. A principal argument runs from negative 180 to positive 180. Now, here when we are getting argument, we are always start from 0 up to 180. We don't go beyond 180. Meaning that in these quadrants, now we move now clockwise. That's why I'm moving from here up here. That's why it's that it's also exceeding negative 180. So we have some examples here. Even that z is that, z2, z3, z4. Then we have these ones. So we want to get their arguments. If I start with now argument of z1, so the solution z1, I'm going to get arg of z1. So that now my arg of z1, first of all, z1 is here. We say you first check the quadrant. It's positive, and there it's positive, meaning that this argument is in the first quadrant. Meaning that we say it's given by tan inverse of the real, the imaginary, which is 3 over the real, which is 4. And there the answer you get is 36.87 degrees. You can leave it in volumes or you can leave it there. Why am I leaving it? Because this one is in the first quadrant. So arg of z1 is there. When I come now to part 2, where I have z2 equaling to negative this. Now my arg of z2 is going to be, now instead I have negative 2, means that it's here, the real is negative, then the imaginary is positive. So see that it's going to be in the second quadrant. In the second quadrant, saying you get 180 minus the truth. Now, after identifying the quadrants, you ignore the signs. So I will say the argument will be 180 minus the truth angle is always in the first quadrant. So meaning that all signs are positive. So meaning I'll be adding now tan inverse of the real of, the imaginary of this, which is 2 root 3 over the real, which is 2. Now here we need to know what signs, because signs are helping us to identify the quadrant. So after identifying the quadrant, you get the truth when all the real and the imaginary are positives. So this will be now 180 minus tan inverse of root 3. I think you get 60 degrees, which will give you 120 degrees, and you start with here. When I come now to argument of z power z3, arg of z3, you first check the quadrant. z3, you see this is positive and this is negative. So positive, negative, so it's this quadrant. So it's going to be now the negative of now the truth. The truth now we say we ignore the signs, which is now our truth is tan inverse of the real. Our real now is root 3. We ignore the signs after identifying the quadrant. I mean our imaginary is root 3 over the real, which will give us negative. This one I think is going to give you 30 degrees. When I come now to Z4, Z power 4, so my I of Z power 4 is that. Z power 4, I mean Z4 is negative, then negative. The negative, the real is negative, the imaginary is negative, meaning it's in the third quadrant. So this is how we get the angle. So you get the negative of 180 minus, now the acute, all the power angles, I mean all the real and the imaginary should be having positive power. So tan inverse of root 3 over 1, like that, which will give you negative 180, then minus, I think this one is giving you 60 degrees, which will give you negative 120 degrees. Now, in there, you can see that always, here we are having a negative, because we are moving in a clockwise direction, that's why even here it's negative, because we are moving in a clockwise direction. So, that's how you get the argument of those things. When you come to part B, they are asking for arc of Z1, then Z2. We said here, you don't waste time. We said arguments are behaving as logarithms. So this will be now, starting to become multiplying. This will be arc of Z1, then plus arc of Z2, which will be Z1 was, arc of Z1 was 36.87, then plus arc of Z2, arc of Z2 was 120 degrees. And this one is going to give you, just add, you have 156.87 degrees, and you are done. You don't need to first multiply. Then see, they are asking for arc of Z2 over Z3. This we say we are dividing, same as subtracting. So arc Z2 now minus arc of Z3. Our arc of Z2 was 120 degrees, then minus arc of Z3. Arc of Z3, my Z3 is here, it was negative 30 degrees, which will give me 150 degrees. When I come now to part D, here they are asking me to get arc of Z or 2. You say if you have a power, then you apply this property here. This power you don't want to multiply here. So this will be now 2, now arc of Z power 4. This will be now 2, our arc of Z power 4. Z power 4 was negative 120 degrees. It is going to be now negative 240 degrees. So I think you can handle this one. The same idea. You are going to be having E. It's going to be now arc of Z power 3, which will be 3. Arc of Z3, which will be 3 into. Now arc of Z3. Arc of Z3 is here. Negative 30 degrees, which will give you 90 degrees. With ease. Now, when it comes to part F, there we need to be a little bit careful. Now, start part F for them, they are just having one part. This one is having the imaginary, this one is having only the real, this one is having only the imaginary. Now, these ones for them, we use the diagram, the Argand diagram. How do we use? So, the argument of Z5, we use the argument of Z5, now we use the Argand diagram. How do we use it? You just sketch. You see, this one is positive 2, but it's real. We say that here is what where we put the imaginary. So here I have 2. Now the imaginary, now meaning that my argument, my complex number Z5 is there. Now, what is the argument? We said we make the argument from the horizontal. So here the argument is from here up to where this is. So meaning now, arc of Z power 5 will be 90 degrees. If it has only, why am I putting 2 here? Because it's imaginary and positive imaginary. We say that always, here we put the imaginary of Z, Here we put the real of z. So because it was imaginary 2, that's why I'm putting here 2. The argument now here is going to be 90 degrees. When I come to this one, so my add of z power 6 is still sketch. Because why do we sketch? Because this one is having only one real party. That's why we sketch. I mean one part. Negative 3, you start this one out as a real part and it's negative. It can't be this side, it's here because it's negative 3. Now the argument means that my z is going to be there. That's why my z is 4. What argument is it making? So from here up to here, you see it's clockwise, anti-clockwise, so it's going to be positive. So it means that now my add of z power 6 is going to be, from here up to here, is going to be 180 degrees. When I come to this now, you start with z7. So my z7, you first plot it. My z7 is going to be, you see, I'm having already imaginary, but it's negative. Imaginary, but it's negative. So this is the axis for imaginary, and this is the axis for real. Because it's negative, it's going to be the sign, so it's going to be 5, negative 5, I. But we don't put I because it's imaginary here. Now start, this is where my z7 is going to be from here to here. So what is the angle from the horizontal? We start doing measure this and it's going to be 90 degrees. But now, here I'm moving it clockwise and clockwise. Saying we attach negative on those arguments. So here the argument of z7 is going to be negative 9 degrees. So you can try and get me z8 when I have it as 2. I wish you the best members. That's how we deal with argument of a complex number. Don't forget to subscribe to the channel. See you.